Well, so I should have mentioned that the process of deciding whether to reject the null and then reporting our results would be step 4, which is to make a decision and report results. So we have successfully completed step 4. All right, so now, however, with an ANOVA, because of the fact that we have these multiple groups, and all that the F-test tells us is that there are differences somewhere, but not necessarily where those differences are, we now need to actually determine where those differences are. So what we're going to do is we're going to calculate what's called Tukey's honestly significant difference test. And in order to do that, we need to find the Q statistic, which is the studentized range statistic, or Q. And so the formula is going to be honestly significant difference is equal to Q, right, the studentized range statistic, times the square root of the mean square within divided by n, and that is the size of the group. Now, I went in earlier and I went to the table, and you need to look up the you need to find the studentized range statistic, or the Q statistic, and you're going to need the K, which is the number of treatments, and you're going to need your degrees of freedom within. And from our table, our degrees of freedom within is 27. The table in your textbook doesn't seem to have 27, so I used a conservative estimate. I had a choice for 3 groups between 3.53 and 3.49, and I chose to be conservative and picked 3.53, which would actually make the difference slightly bigger. So we're going to say, okay, 3.53 times the square root of, and the mean square within is 1.45, right? And we're going to divide that by the number of observations within each of the groups, and that's 10. All right, so we're going to go here and we're going to say 3.53 times the square root of 0.145, and that's going to be equal to 3.53 times the square root of 0.145 is 0.381, and that's going to give us an HSD, an honestly significant difference, of 1.34. Now, what we're going to use this for is to evaluate whether the difference between the means is greater than this value, right? So this is basically saying that the magnitude of the difference between means must exceed this value of 1.34 if we're to consider them statistically significant at alpha equals 0.05. So here's what we're going to do. We need to actually calculate the difference between means, and it's been a little while since we've looked at them, but we go back to our table. We know that group 1 had a mean of 1.4, group 2 had a mean of 1.5, and group 3 had a mean of 5.4. So what we're going to do is we're going to calculate the difference between means. So mean 3 minus mean 1, mean 3 minus mean 2, and mean 2 minus mean 1. All right, and we know that mean 3 is 5.4, and mean 1 is 1.4, and so that's going to give us a value of 4. And then mean 3 minus mean 2 is 5.4 minus 1.5. That's going to give us a difference of 3.9. And then finally, we're going to have 1.5 minus 1.4, and that's going to give us a value of 0.1. So, as I mentioned, our HSD is 1.34, so what we need to ask the question is, are our mean differences greater than 1.34? Well, it's pretty obvious that the difference between mean 3 and mean 1 is greater than 1.34, and the difference between mean 3 and mean 2 is greater than 1.34. So I'm starring them to indicate that those two differences are statistically significant. However, we can also see that the difference between our means is not, sorry, this is one of those little challenges here. The difference between the mean for group 2 and group 1 does not exceed 1.34, so we're not going to star that because it is not statistically significant. So the last thing we need to do then is we need to write these out in language or words that your grandmother would understand. So I'm going to type that out so that it's easily visible. And so what we're going to say is that alcohol as compared to no alcohol increased the number of driving errors on a video game task. Right. Alcohol is compared to no alcohol increase, so we could even make this easier and just say that alcohol increased the number of driving errors on a video game task as compared to no alcohol. Right, and we'll say that's period. Alcohol also increased the number of driving errors made on a video game task as compared to placebo. Goodness gracious. There was no difference between the placebo and no alcohol group in terms of the number of errors made. Okay, and that is it. And that's basically how we calculate our one-way ANOVA, how we determine where the group differences are, and how we report our results. All right.